Hello everyone, welcome to another video. Thank you so much for joining us. And as promised, we are going to talk about and solve the problems on the Ranalah half wheel. A couple of weeks ago, I took it down to Jeff Moss at MPH Motor Panels. He has been my go-to guinea pig for this whole Ranalah journey for the last 3 years or so, testing out all the different modifications and prototypes and bits and bobs along the way to get to the point where we're at now. I completely trust whatever Jeff says, basically. Jeff has a lifetime of experience using these machines. He's one of the most talented people at using the wheeling machine that I know. He also teaches it. So if you're interested, if this journey of wheeling machines has inspired you to want to learn, book yourself on with some time with Jeff at MPH Motor Panels. Go on his website, message him on Instagram and let him know that you've come from one of these videos, and I'm sure he will look after you. We're not with Jeff today, but we do have another special guest and another very, very talented person. My good friend Paul has been involved with the Ranalah journey from the very start. That very first machine that I found and stripped down, he 3D scanned it, and he's very, very clever with computers. He makes the most incredible pieces of art, sculptures, model cars, abstract furniture, all designed on the computer. And he's been so helpful, turning my rambled scribbles on pieces of paper into a computer file, which eventually turns into reality. After spending the time with Jeff and realizing the half wheel needs some fairly major surgery, obviously my first call was to Paul, because he's got all the 3D models on his computer of this half-sized wheel. And some serious modifications need to happen. Today's the day. We are going to spend the morning, hopefully, fingers crossed, solving all of the problems that we had with the wheel, with the prototype wheel that was down at Jeff Moss's. So Paul has just sent me a file and emailed me and said, I'll explain all later, just cut this out on your plasma table from some steel. I've got a piece of 2mm sheet steel left over from making the giant spanner for Goodwood. I don't know what it is, but I'm sure it's going to be helpful.
Start.
Hey Dom.
Hello.
Hello.
Welcome.
Hello matey.
It's like Christmas all over again.
Happy New Year.
Yes. This is it.
It is. I haven't put it together, but I think it will work.
It's been a while since I've actually built a puzzle, especially one as complicated as this. I've got the steel cut as requested. Paul has spent the last, few days? Well, it's been more than a few days.
Three
a week,
or 4 days, yeah.
Day and night. Printing a scale model of the half wheel, the Ranalah, in 3D printed plastic, all in sections. Yeah. So Paul somehow has managed to, a printer that can print A4 size, to print a metre tall model of the Ranalah, with the modifications that we've had to make to allow for more clearance. And the end result is lots of big puzzle pieces like this, which today we're going to glue together, fingers crossed, and everything in that tub should make a little flat pack Ranalah.
Let's hope so.
The arc around the top.
Yeah, there's your bigger wheel, the size of that.
Oh, nice. Jeff will be pleased with that. He better be anyway.
Let's hope so.
That's a lot bigger.
So this is 150mm now.
Oh, okay,
What's
that's
this one?
120.
120.
If you've seen the previous video, we took the working half wheel down to Jeff Moss, and he wanted to make some changes. He wanted the top wheel to be heavier, wider and larger diameter, and the lower wheels to also be wider and bigger. The gap between the top and bottom wheels, there was not enough gap to increase both wheels and actually still be able to get the lower wheel out. Paul has come up with a solution, modified the drawings on the computer to suit the new wheels, and made the amendments needed on the frame. And then we've got a 3D printed model, which we're going to build to prove the changes, to make sure you can actually get the larger wheel out of the cradle. I think that makes sense.
We needed to make sure the machine still looks like the Ranalah, right? So that we couldn't adapt the shape too much.
Visually. Just purely aesthetics.
Yeah. So in order for us to fix this issue, you can't just increase the height or increase this because proportionally it wouldn't look like the same machine.
Yeah.
So we've done a combination of both. We've lifted this no more than sort of 8 or 9 mil, and we've increased this angle here by only a couple of degrees, and that's enabled us to get the right aperture we need in here.
Whilst I was at Jeff's, I was thinking one simple slice there and put 2 inches in there.
Yeah.
But that would have made it look really tall and gangly and odd.
It's a subtle change, but it actually has quite a big effect. I think the 3D print hopefully will prove that it was worthwhile doing it.
Yeah. Done.
Yeah. There's a bigger cradle.
The lower wheel originally was 50 mil and now they're 70.
Yeah.
This is the issue. If this wheel was any larger, you wouldn't be able to get it out. And I'm very glad that Paul has spent some time redesigning it and redeveloping it and solving the problem. And hopefully this is the solution.
Yeah. So you've got a bed, and this is in PLA, which is okay. You can get many different plastics. PLA is sort of a general plastic.
Yeah.
And once you import it from your computer software, the bed basically drops down, and each time it drops down, it prints another layer.
Oh, I see. So the nozzle doesn't move. The bed moves
yeah.
down and it
Yeah.
prints a layer,
Yeah. So you've got 3 axes. So the head moves in 2 axes, and the bed moves down. Yeah.
And it's like a glue gun squirting out. Just does a layer,
Yeah.
moves down, does
Yeah.
a layer.
Yeah.
Wow.
That's exactly it.
I can see why that's taken so long.
This is the surface that adheres to the print bed. That's why it has that slight finish on it.
So that's the start. That's the
That's
very
the starting
first
point.
layer.
So that's the bottom layer.
Okay.
And then you can just work out here the layers as it comes up. This surface isn't exactly flat. Right, where it is flat, you can see the layer is smooth.
Okay.
But as there's a gradient where it comes down, you can see, literally looks like a map. So you can print in different densities. So the things like the cradle, I've printed that at 100%, so that's really strong.
It's solid.
That's really solid. And this would take so much plastic and so much time, so you can increase or decrease the density.
I see. So inside there is hollow.
It's not hollow, you can choose. This one is just like a web, but you can choose different infills on the
like
program.
a honeycomb, like
like
a cheap interior door has that kind of like...
Yeah, I mean, we don't use the word cheap, but yeah.
Let's try and get it together. Let's see. The foundry pattern is in 2 parts vertically. So they come apart left and right, vertically down the middle. And you can see the parting line on the casting very faintly because Chris does such a nice job at the foundry. So this is broken in the same way. So we've got left and right sides.
So if we build this side up first, but anything that doesn't have a bit of tape on is this side. Does that make sense?
Okay, fine.
Anything with tape on is the other side. So we'll put the tape on over there.
Oh, you've made it easy for us.
Yeah. Right,
That's there.
that should be it.
That's the top. That's somewhere there. That
That's
is
there.
here. That might be there.
That's there.
Oh no,
That's there. Is that better?
that's good.
So in other words, is this one?
Oh, then that. Yeah,
Is that right?
that looks good.
All right, so if you go one at a time, they're tight fits, so push them down horizontally.
Oh,
Yeah?
that's quite satisfying.
It's good, isn't it?
Yeah, that's nice.
Yeah.
That locks it in.
Yeah, yeah, yeah.
It's like a dovetail, isn't
It
it?
is a dovetail, yeah. Let me just show you on here. This is obviously just one side, and we haven't got the weight of this on. And even though they're tight fit, there is a very slight movement that way. And it doesn't wobble on its own, but when you've got the weight of these extra bits, it can open up. And the problem with that is it compresses this angle here.
Yes, which
Right?
will then, it won't give us a true measurement of clearance.
yeah.
Where the cradle is, that
Yeah.
you can see the difference there. So we've actually gained 30 mil or
30
so.
mil? Yeah. But it still
Perfect.
looks, if you put it there, it still looks like,
It's still, you wouldn't know.
no.
Even looking at them side by side, it looks
yeah,
the
yeah.
same. Handy having clever mates.
Because if we glue one in the wrong position,
We're not going to do that.
yeah, I know.
Are we?
I've seen your videos. Yeah. Because
Nice.
we can't afford to get any glue on the underside because that will push the 2 halves apart when you clamp it together.
And it will also stick it to the metal.
Yeah.
And we don't really
Both
fancy,
those
I don't
things.
fancy that happening.
No, nor do I.
That's it. Fine.
Good.
Done.
There you go.
Perfect. Should we crack open the glue?
Yeah. You don't need huge amounts of this stuff.
Kirsten's probably watching this now, thinking what they're doing with that adhesive, honestly. Lay it down, nice and flat, line it up with a jig. Happy?
Yeah. There you go.
Done.
Right, shall I have a coffee?
Yes, after that, yeah. Up here. I'm very nervous.
You should be.
Up there, over there, in the dovetail.
It's more jeopardy because every time you add a piece,
It gets more and more
You're gonna-
stressful.
yeah,
It's
you're
like
gonna
playing a
ruin-
computer game. You're getting further and
Yeah,
further
yeah.
along the level. Oh, no! Oh, look.
if you put it more towards the bottom, when you push it in, the glue pushes it up.
Squidges up. Okay. Oh, that's such a satisfying sound. Perfect fit. And that is the last piece of one side done. I think he's already standing it up. Instant. This is a very instant process. It's quite strange for me just turning a random pile of parts into now full size to scale mock-up of half of the Ranalah. We've got to do that again on the other side. And this is the critical part, that the other side matches up exactly to this side. That's why we've got this steel sort of spine. So we can flip that spine over and do exactly the same again on the other side. And then we'll have two halves.
We can temporarily fix these with bolts or on this central spine because it's a flat surface. But when you get to this area here, you see that there's nowhere to fix in.
Yeah.
So what I've done is I've made these, I don't know, should we call them butterfly tenons? So they push in there. So we can slide this whole section into here. And then when we bolt, this is already attached. What I've done is then, as well as that one, I've got half size ones. So you can actually make that back to be a solid.
Okay.
Yeah?
That will fill in and make it flush.
Yeah. And then again, if you were to print it, then I've printed these half, so that could fix in there.
And make
So
it
if
solid.
you want to cast it,
Yeah.
then it becomes solid. So I've also done a half round for in here as well.
For the axle.
Yeah.
I'm trying my best to explain how much thought has gone into making and designing and drawing. It's a lot more than just scaling down a 3D model of the Ranalah and then printing it out. There's so much that Paul has had to think about with jigsawing it all together. The jigsaw joints are staggered side to side like a brick wall, so the joints are not next to each other. There's so much to take into consideration to make an accurate model, which is what we need to actually prove that we can get the wheels out. There's enough clearance and it doesn't look odd.
I design replacement car bodies for independent builders, so you can actually physically see it and, you know, hold it. So yeah, I've done mad things. I did a bobsled for the guys who designed the bobsled for the US Olympic team. They wanted to recreate this bob to go down Lake Placid, and it had to be adapted for safety.
Okay.
So we designed it in CAD and then 3D printed the bobsled.
Wow.
So that we know it worked. And then in America, they just printed out the bobsled full scale. And then the guys
They
filmed
3D printed it to...
Yeah. And the first time I saw it, there was a shot of the bob with a 3D printed body coming down
Wow.
past. Yeah. So yeah, a lot of times I'm in freezing cold workshop with mates putting bits of plastic together.
With an annoying dog whimpering in the corner.
Yeah, that's the majority of the time. So you get extra strength. So I've designed the connections so they're offset. So when we bolt it together, you're going to get increased strength as well. And obviously, like the real machine, as this will be, these are all draft angles.
Yeah.
So if you were to use this as a mold, effectively, you could sink it in and then it would release
It comes out of the sand. Yeah.
properly.
Success. Both halves line up so nicely, and that is a very stable scale model of the half wheel with the modifications.
Ours isn't on the feet yet. Yeah.
Oh, of course, yeah, we haven't got the feet. Yeah.
There you go.
That's actually really good. It's really good.
Yeah.
You would not, honestly, even side by side,
You can't really tell.
you still can't tell.
Good.
It looks identical, even the height. Yeah, it literally looks the same. This brings us on quite nicely to the next part of the challenge. All of the inserts, all of the sort of turned parts, the threaded insert, the keyed insert, the axle for the top wheel. We've got all those components to size as they are on the original machine, all 3D printed with the little broached section. It should actually work. Wind up and down.
Yeah.
The lower cradle should move.
Yeah.
This is very exciting.
You'll be able
Very
to bend
exciting.
paper in it.
Yeah. Before we put the inserts in there, Paul has got another treat for me. This little horseshoe is going to make life so much easier for me. When the castings turn up from the foundry, just as rough castings, there is no reference to where the middle of the hole, where the middle of the casting is, where the sort of center is, and you need to find that center to drill the hole. If you get that first hole in slightly the wrong place, by the time you make it 40 mil, you end up very close to one edge and it goes off center, which is exactly what happened to this casting. I drilled the hole off center, the casting's ruined. Hundreds of pounds gone, there's no going back, it's done. But Paul has a solution.
So with this, you'll be able to slot that over the casting. Then that is a 10 mil hole. And what's this called?
Transfer punch.
So that will drop down and mark exactly, yeah, where it's to go.
Because this has obviously been designed on the computer, Paul is able to tell where the center of these holes are in relation to the frame, which sets where that hole is drilled. So that, if that's pushed all the way in, that is bang on in the middle, left and right and front and back of the casting, where the hole needs to be for the insert to fit, which then dictates where the cradle sits, which then dictates where the top wheel sits in and out in relation to the cradle. It's all relevant and it's all going to come from that hole. We've actually increased the width of the casting here just to give it a little bit more material around the outside edge, because if you look at the original casting, once I drilled the 40 mil hole, things started to get a little bit thin around here. It's perfectly fine, and this is the same as the one that Jeff's got, which has withstand me using it and it been at Goodwood Revival, but it's a little bit thin, and whilst we're modifying the pattern, I've made it a little bit fatter. Before we actually start installing these components, there is another benefit to making these modifications. On the original full-size castings, the holes in the casting are cast, they're made, it's in the patterns, they're cast in, so they turn up here with big holes already in them. That does not work for these small ones. I have to drill the holes, which is why I bought the mega drill. The shape of the casting meant that I need to drill this hole first, that hole, then that hole. But if you look from the side, Paul, grab that for us. Because that drill is so big, like the actual tool holder is ginormous, and this is a reamer to ream this hole to size. As you can see, look, the clearance, as you start to drill the hole, imagine this is a drill bit, the actual tool holder hits the top of the casting before you can drill the hole. So no any tooling that fits on the mega drill wouldn't allow me to drill the hole. That was a massive problem, and I ended up getting around it with stacking up adapters and using thinner diameter extensions. Everything starts to become a little bit more unreliable. The whole point of having a big solid mega drill like that is so it's strong and solid and big and fixed in position. As soon as you start stepping that down to smaller adapters, you lose any kind of accuracy. Whilst Paul was redesigning this and we were moving the castings, it's like this is the perfect opportunity to give me enough clearance so I can put the proper tool in the tool holder on the drill as it's supposed to have, and hopefully it will clear. Are you nervous?
No.
Oh, I'm so pleased with that. That now I can drill both of these holes and knowing that the tool holder will clear the casting with 3.5 mil. Precisely. Right, onto the inserts. Come in there, Paul. What have we got? More 3D printed parts.
These are basically the same as on the real one, but you just wanted these things scaled. So, I don't know, what's that? Is that keyway?
Yeah, yeah, exactly.
A nice fit in there.
That's a threaded insert, yes.
Yeah, but obviously I didn't really want to thread the plastic, so what I did is I 3D printed it to fit an M12
with
nut.
a hex. Oh, nice.
Yeah, so although the thread doesn't go all the way through, it effectively does the same thing.
And that's pushed in there, so that's clever.
Yeah. And again, you wanted to be able to access this.
It needs to go in from the top. Yeah, see, that's as tall as it possibly could be.
Yeah, so we can't go any taller than that.
Yeah.
So this is just an M12 120mm bolt. So I've printed the handle in 2 sections. The head of the bolt is encased in there.
Okay.
So now we know that.
Yeah.
You got that?
Brilliant.
And then this, you was talking before, we had 0 tolerance in these bits, connections. This has 0.1 or something, I think.
So it can move.
Yeah. So
okay, wow.
So it's still a nice fit. There's not much play, but it enables you to drop that down.
I was honestly not expecting this level of detail, but this now leads us quite nicely on to the cradle for the lower wheel, which is another big change that we've made, but hopefully one that keeps Jeff happy. There's only 20mm difference, 10mm either side, but it makes a big difference when it comes to the actual profile for the wheels. So many people commented saying there's a massive gap between the lower wheel. Why don't you just redesign the cradle and remove that gap, and that would give you the clearance that you need.
You can't reduce that void because you need this adjusting screw to alter the angle of this. And if you lower this gap, you don't have any space to put this screw in or adjust it. So you have to gain the height elsewhere, which is why the overall concept is to lower this fractionally and increase that so you get the space you need. We're not trying to make a plastic machine. What we're trying to do is to prove that when you make a real machine, it works. That's the purpose of this print. The idea is that Dom can choose, or Jeff in conjunction with whoever, we can actually reduce this wheel down to 65 or 60mm without redesigning the cradle.
Yeah.
So we've gone for the maximum size.
That is as big as it could be.
Yeah.
Which is massive.
Yeah.
Jeff really wanted the width, and that is all to do with the profile of the wheel. He doesn't necessarily need that diameter. It won't make a massive difference. If I take 5mm off that, make it a little bit smaller. But to be fair, that looks nice. You can already see there's a lot more room above it. So what's next?
Big wheel.
The top wheel.
The axle is quite critical because this axle length is the right length that when it's placed at the furthest point back here, that is the right gap here by default. So obviously when you make the axle in metal, you'll obviously have a shoulder or something there to keep that wheel at that point.
Yes. That's what we've got on the, yeah, exactly.
But at the moment you haven't got that. So just for ease, if this is flush here and it's flush at the back, this gap is always going to be correct.
The top wheel was a big problem because it didn't have enough weight behind it to sort of pull the panel. You've seen Jeff, the way he rolls the wheel and then it sucks the panel in. This top wheel now is wider. It's 10 mil wider and 30 mil larger diameter. So I'm really chuffed with that. It's a lot bigger, it's wider, it's a lot heavier. It's going to be a lot heavier, which means it's going to be more expensive, annoyingly. This is the critical part. The clearance between that bigger top wheel, bigger diameter bottom wheel, everything's got bigger, but have we made enough space in the frame for it to all actually fit?
Look at that clearance.
Loads, yeah.
There you go.
Absolutely brilliant. The casting, the frame, just looks perfect. It looks exactly the same. Plenty of clearance, a lot more clearance than we ever had before to get that lower wheel in and out. As I start making components in steel, we can actually fit them to this model and sort of see how things are working. Like this is a steel cradle from the actual working model, and it fits perfectly on here. You can actually use it as a practical prototype for a working sort of model. The only thing I'm not sure on is this lower wheel. This is 70 mil. The original one was 50 mil. I might go somewhere in the middle. The beauty of this is that is just another 3D print. Print another one, slot it on there and then have a look, instead of hundreds of pounds of making ones in steel, which is what we've been doing previously. So many people commented saying, why don't you just use the full-sized wheels from the full-sized machine? The full-sized wheel would look really awkwardly too big for this size casting. Also, this is a machine designed for somebody that's learning the craft and somebody that wants to sort of develop their skills. It's an achievable, a more affordable version of the full-sized wheel. So by having the narrower wheels and the narrower top wheel, it's just making it different to the full-size machine. Well, Paul, thank you so much for coming down. I know it's been an awful lot of work for you, so I'm so grateful. Thank you very, very much.
No problem.
Anybody out there that could use Paul's services, go to his Instagram. What is it?
Modular 105 motor.
There you go. Have a look at his Instagram. Get in touch with Paul. If you've got any obscure, random, strange projects like this, Paul's your man. He'll help you out. Look forward to seeing your inbox now.